In this video, we're doing another example of factoring trinomials by pulling out the greatest common factor. And remember that trinomial, tri means 3, so trinomial is just a polynomial, but with 3 terms specifically. So in this first example, we have a cubed x squared m squared plus a squared x m cubed minus a to the 4th x cubed m squared, and we need to find the greatest common factor among these 3 terms and pull that out in order to factor the trinomial as completely as possible. So when we say the greatest common factor, we're talking about the largest value that we can pull out of each of these terms. So we can see right away that we have the variable a, the variable x, and the variable m in all 3 of our terms. We're going to want to look at each of those separately. So if we just look at our a terms, in the first one here we have a cubed, in the second term we have a squared, in the third term we have a to the 4th. In other words, we can think about this as a cubed, a times a times a squared as a times a, and a to the 4th as a times a times a times a. So what's the largest value that's common to all 3 of these? Well, that's just going to be a squared. In other words, 2 factors of a. Because if I pull out 2 factors of a, I'm just going to be left with 1 here. I can pull 2 factors of a out of here, and I can pull 2 factors of a out of here. I can't pull out 3 factors of a or 4 factors of a because that's more than I have in this second term. So I can only pull out 2 factors of a. That's sort of my limiting factor. So pulling out 2 factors of a, I'm going to get a squared, and when I take a squared out of each of these 3 terms, that's just going to leave me with a single factor of a, or a to the 1st, so then I'll also have x squared, m squared. Here I'm pulling out both factors of a, so I'm just going to be left with 1, so I'll have 1 times x times m cubed, or just xm cubed. We don't have to write the 1. And then here I'm pulling out 2 factors of a, leaving me with 2 other factors of a, so I still have minus a squared, x cubed, m squared, like this. Now I want to look at my x values here. I have x squared, x, and x cubed, so I really need to remember that that's x times x here for x squared, that here I have x and here I have x cubed, so that's x, x, and x. Now, what's the largest number of factors that I can pull out of each one? Well, here I'm limited by the fact that I only have 1 factor in the second term. I can only pull out 1 factor. So I'm going to pull 1 factor out of this, and I'm going to pull 1 factor out of this. I can't pull out 2 factors or 3 factors, even though I have those here in the first and third terms respectively, because I'm limited by the fact that I only have 1 factor here. So I'm going to pull out that 1 factor of x, and so then in the front here I'll have a squared x. And when I pull out the single factor of x, I'll be left with a, and then just the single factor of x left over here, m squared, plus, removing this factor of x just leaves me with 1, so I'll have 1 times m cubed, or just m cubed, and then minus a squared, pulling out 1 factor of x leaves me with 2 factors, so I'll have x squared, m squared. Now I need to look at my m's. I have m squared, m cubed, and m squared here, so I can think of that as 2 factors of m here, 3 factors of m here, and 2 factors of m here. And I can only pull out 2 because 2 is the largest number of factors that is common to all 3 terms. I can't pull out 3 even though I have 3 here because I'm limited by the fact that I only have 2 factors in the first term and 2 factors in the last term. So pulling out just 2 factors of m, or m squared, I'm going to get a squared x m squared, leaving me with a x, pulling out the entire m squared here. I'm just left with 1, but I don't have to write the 1 because it would just be 1 times ax, or just ax. Pulling out m squared here, I'm just left with the single factor of m, and then I have my a squared, x squared, and pulling out the m squared here, I'm just left with 1, so I leave this as a squared, x squared. Now that I've pulled out the largest number of factors for a, x, and m, I know I've factored as completely as possible, and I can say that a squared, x, m squared is the greatest common factor of the 3 terms in my trinomial, and this whole thing I have here in the last line is the trinomial factored as completely as possible. Let's do one more example here. We have 6a squared x squared plus 2a cubed x cubed plus 4a to the 4th x cubed. So notice that I have a's and I have x's, but I also have these constant coefficients. The coefficient on the first term is 6, the coefficient on the second term is 2, the coefficient on the third term is 4. So in the same way that I factored out the largest number of factors of each of the variables in this first example, I'll have to do that here. I'll also have to take out the greatest common factor of the coefficients, 6, 2, and 4. So looking at 6, 2, and 4, I know I'm never going to be able to take out a number larger than the smallest number. 2's the smallest number here, so I know I'm not going to be able to take out anything larger than 2. Can I take out 2 itself? Well, yes, I can, because 6 divides by 2 evenly, we get 3. 2, of course, divides by 2 evenly, we get 1. And 4 divides by 2 evenly, we get 2. So we are able to take out the 2. So I know I'm going to be able to take out a 2 here. Then looking at my factors of a, I have a squared, a cubed, and a to the 4th. I'm limited by my a squared. That's my smallest number of factors. I have 2 factors here, 3 here, and 4 here. I can't take out more than 2 because this term only has 2, so I'm only going to take out my a squared. And then for x, I have x squared, x cubed, and x cubed. I know I'm not going to be able to take out more than 2 factors because I'm limited by the fact that I only have 2 factors in this first term. So I'll take out the x squared. So then, when I factor this out, taking 2 out of 6 leaves me with 3, because 2 times 3 is 6. Taking a squared out of a squared just leaves me with 1. 3 times 1 is still 3. I don't need to write that extra 1. And taking x squared out of x leaves me with 1 also. And again, I don't need to write the 1 because this is really just 3 times 1, which is still just 3. So I have 3 there. Then taking 2 out of 2 leaves me with 1. Again, the 1 is redundant. I don't need to write it. Taking a squared out of a cubed just leaves me with a, because remember, a squared times a gives me a cubed. And taking x squared out of x cubed just leaves me with x. Then here for our final term, taking 2 out of 4 leaves me with 2, because 2 times 2 is 4. I have to multiply a squared by a squared in order to get back to a to the 4th. And I have to multiply x squared by x in order to get back to x cubed. So just to double check myself here, I look at my constant coefficients. I have 3, 1, and 2. There's no common factor that I can pull out there. Looking at my a variables here, there's no a variable in the first term, so I can't pull out any more factors of a. And looking at my x variables, there's no x variable in this first term, so I can't pull out any other factors of x other than what I've already taken out. So I know that 2a squared x squared is going to be my greatest common factor, and that I've factored the trinomial as completely as possible.